Hey 7th graders, today's lesson is 2.1 and 2.4 natural selection. Your learning targets for today, I can explain how adaptive traits are passed down from generation to generation. So we're going to take a look at adaptive traits and how that influences reproductive rates of organisms and how that can either promote or prevent certain adaptive traits or non-adaptive traits from being passed down. Keep in mind, one of the things I've been reiterating throughout this lesson is that just because an organism has a non-adaptive trait for an environment doesn't mean that they're going to go extinct and that they're all going to die, okay? It might mean that maybe they're preyed upon a little bit more, but some will still be able to survive and reproduce, just not as successfully as those with adaptive traits. So keep that in mind as we roll through this lesson today. All right, activity 1 today is a little addition to your notebook. You're going to open up your OneNote. Add gene and protein molecule to the vocab page of your OneNote. These both should be a review for you from our genetics unit. Okay, so gene, as you remember, is an instruction for making a protein molecule. So it's a little segment on our DNA that codes for a specific protein molecule. Maybe it's the protein that makes my eyes brown. Maybe it's the protein that makes your eyes the color they are. Okay. And then again, the protein molecule is a type of large molecule that performs important functions inside organisms. So again, that might be something like your eye color or your skin color or your hair color, or it could be something like how your body processes sugar, okay? So not only what you look like, but how your body functions as well. All right, let's move on to our warm-up. So you guys have seen some of these before. This is a little Sherman story for you guys. So this talks about bird beaks and kind of ties in with the lab that we did last week where you guys had different bird beaks and got to see how successful you were at eating certain types of food. Okay, so you guys can see what old Sherman and his little fedora or whatever those things are called is up to. So these birds are so amazing. Their beaks are so tough and strong. Did you know that very long ago, most of these birds did not have very strong beaks? Some scientists thought that these birds today have such strong beaks because of the food that was available for them to eat. Oh yeah, I've heard of this. The birds really needed to have strong beaks so they could crack open the hard shells on these seeds. They grew stronger beaks so they could eat. Actually, Sherman, while it may be true that the birds needed stronger beaks to eat those seeds, they can't just grow stronger beaks because they need or want to. Just like you can't grow taller just because you need to reach food on a higher shelf. Oh, of course. So the birds with weak beaks all had offspring with strong beaks so they would survive. Well, Sherman. Okay, so you guys are going to respond to that little story about Sherman. So in this environment, which trait is adaptive for birds? So what trait are we looking at that can either make with this environment we just discussed in that comic, that's either going to kind of make that bird more successful or less successful? Okay, did these birds choose to have the adaptive trait? That's pretty much coming right out of that context there. And then Sherman suggests that reproduction always creates individuals with adaptive traits. Does this seem correct? Why or why not? Okay, so like he kind of ended up saying, all right, well, the birds with the weak beaks then had babies with strong beaks and all was fixed and better. Okay, all right, so moving on, activity 3 is the sim, and this sim is kind of a two-part activity. So what you guys are going to be looking at is this claim here that says reproduction always creates individuals with adaptive traits. Again, that really feeds off of what Sherman brought up by saying that, you know, the birds with weak beaks will have babies with strong beaks. Okay, so that would be reproduction creating individuals with adaptive traits, which are the strong beaks. Okay, so yellow color is adaptive in the yellow 7 environment with carnithons. So again, this is with predators. Having that little bit of camouflage kind of should help those yellow 7 australopes out. So do you think all australopes who reproduce will create offspring with the adaptive yellow color trait? So if we have a blue or a green or something, a different colored australope running around, are they going to have offspring with that yellow 7 or close to that yellow 7 color that's going to make them more successful? Okay, all right, so that's what we're going to be studying in this sim. Observing reproduction in the natural selection simulation. So your goal is to gather evidence to support or refute the claim that reproduction always creates individuals with adaptive traits. So you're going to open up the sim and go to the mode of reproduction claims, and I'm not going to do all of this for you per se. So we're going to open that up. It'll ask you, are you using an iPad? And you'll say no, unless you guys, of course, are using an iPad. Okay, and then you guys are going to go to this reproduction mode up here. So this corner right here, you'll see the 3 horizontal bars. We're going to find reproductive claims and load that up. Okay, press run to complete the data tables below. Slow down and pause the sim to carefully observe traits after reproduction. Reset the sim between trials. If the australope you are following gets eaten before it reproduces, select and follow a similar australope. Alright, so this is what you guys need to record in this. So for the first trait, you're going to look at australopes with non-adaptive traits. So select and follow an australope that does not blend into its environment, one that has a non-adaptive color trait. Follow the australope until it reproduces and then pause the sim. Observe and record the color trait levels of both parents and the offspring in the data table below. Alright, so I'll do this first one with you guys. I'm going to zoom in just a titch here. Okay, so I'm going to zoom in here. Notice that we have our Carnathons here, and then we're just going to go ahead and hit next and run this bad guy here. And then we're going to find one that doesn't blend. So this one doesn't blend right here. We're also going to slow it down so we can really pay attention to what happens. He might get eaten. If he gets eaten, I'm glad he got eaten. Well, I'm not glad he got eaten. If he gets eaten, then you're going to find another australope that doesn't necessarily blend. So you guys can zoom out, zoom in as you need. This guy I can see doesn't blend. He's also in the process of getting eaten. So we're going to just follow this guy right here. Where's our little dude? All right, here we go. So these guys are blue. They just had a baby. It's also blue. So, oops, pause the sim. Let's go and check these ones. So these two were the parents. This australope right here is color trait 1. This one is also color trait 1. And notice they had a baby that was color trait 1. So trial 1, I would do color level was 1. Color level was 1 here, and their offspring was also a 1. So notice that it didn't have the yellow 7 color. Okay, then we're going to go ahead. It's, again, easier if you guys slow it down. Okay, and find one that doesn't blend. Maybe we find a green one this time. Okay, here we go. This guy here. He's a color 8. He doesn't blend super well. And so we're just going to watch. Oh, did he get eaten already? Here's some that don't blend. Okay, they're having a baby. Let's go ahead and pause them and zoom in. Okay, so this australope right here is color trait 6. This one's also 6. Let's see what their babies look like. So here's their baby. We'll pause on him. And also color trait 6. So then I would record in here color trait 6, color trait 6, and color trait 6. Ah, nuts. There we go. Okay. So if you guys will do that and collect your own data. I'm gonna go ahead and delete that from you guys. So you guys can collect your own data on that one. And then for the second one, you guys are gonna look at australopes with adaptive traits. So select and follow an australope that blends into its environment, one that has the adaptive color trait. Again, you're gonna follow it until it reproduces. You're gonna pause it. You're gonna look at what the 2 parents were and what the offspring were. You're gonna record it. And then you're going to do that twice. So then you're going to pick a second australope that does not blend, or that is blending, excuse me. And then answer this question. Think about if the data you collected in the sim supports or refutes the claim that reproduction always creates individuals with adaptive traits. Okay, you collected data about 4 offspring. How many of the offspring that you observed had the adaptive trait of yellow color 7? So you guys will use your draw tool to circle either none, some, or all. So there's only really one answer for that right there. Okay, moving on to the second part of the sim. Let's take a look back to our little poison rough-skinned newts here. So when we're looking at those rough-skinned newts, remember that their skin has this chemical on them called tetrodotoxin that is poisonous. So if we were to eat a newt, we would probably die depending on the amount of poison in that newt's skin. Okay, so poison level 10, which is the most poisonous, is the most common because the newts with this trait were able to live longer than other newts. Okay, so those with poison level 10 automatically live longer. Okay, poison level 10 is the most common because the newts with this trait reproduce more than other newts. Okay, so we're going to look at which one of those little claims right here is probably more accurate. So here's how we're going to do this. Okay, considering why the distribution of traits changes in a population. So why do we see those adaptive traits become more common? Consider the key concept. Individuals inherit their genes from their parents. Genes and therefore traits in a population are passed down from generation to generation. So those traits could be adaptive or they could be non-adaptive. Consider the investigative question. How do some traits become more common over many generations while others become less common? So this might be looking at the poison level here in these newts. Share your ideas about the investigative questions. You don't have to do that part. Okay, so here's what the sim is going to look like for you guys. Gather evidence to support or refute the claim that Australopes with adaptive traits have more offspring than Australopes with non-adaptive traits. Okay, so do they have more offspring or do they just live longer? Okay, so you're going to open up the sim, which should already be open for you guys, and we're still in reproduction claims, so you guys can just kind of reset the sim here. And again, you should still be in reproduction claims for this one. Okay, this one's fairly easy to gather evidence. So open the natural selection simulation and open the mode reproduction claims. Zoom into the environment in build and select an Australope with one of the color traits in the table below. Press run and count the number of times that Australope reproduces before dying. Record the number in the data table below. Press reset in the sim, select an Australope with another color trait from the table, and then run through that data collection as well. So tips: if the Australope dies before reproducing, record a 0 in the data table. All right, so here's what your data table looks like. We got number of offspring: blue 1, blue 4, yellow 7, yellow 10. So those are the 4 colors of Australopes that you're looking for. All right, so we're gonna go in here. I'm gonna need to zoom in. I reset, so we're gonna go to build, reset run. Nope, we're gonna go to reset build. There we go. And then we're going to look at Australopes with different colors. I don't think we actually have to change any of these. So we're just going to go ahead and zoom in. And we're going to find one that has a color we need. So here's yellow 8. We don't need that color. Here's yellow 2. Don't need that color. 6, 5, 3, 1. Okay, so 1 is one of the colors, I believe. So let's double check. We need blue 1. Alright, so we're going to go ahead, we can slow it down a little bit, and we're just going to watch and see how many times this guy reproduces. So there's once right there. Oh, look at him go again. 2. Eating a tree. Oh, predators in the area. He seems unfazed. Oh man, there he goes. Alright, so he definitely got eaten. He had 2 chances to reproduce though. So here we're going to go ahead and record on a blue 2. He had 2 chances to reproduce, or she, or whoever it was. Okay, then you're going to find a blue 4, a yellow 7, and a yellow 10 as well. And then once you guys have that done, you guys are going to open up this link right here called the class data link. So right click it, open link. And then you guys are going to pick the next available student. And you guys will click on the plus sign to enter your numbers in, and then we'll be able to look at a graph of our class data. So once you guys have your data table filled out there, make sure you guys add your data into there. And then answer these 2 questions. Australopes that lived longer had more, fewer, or the same number of offspring than Australopes who did not live as long. Okay, so you guys are going to use your draw tool to circle either more, fewer, or the same number of. And then claim Australopes with adaptive traits are more likely to reproduce than Australopes with non-adaptive traits. So do you think they're more likely to reproduce or less likely to reproduce if they don't blend in as well with their environment? Okay, does the data from the entire class support or refute this claim? So again, go into that class data tool, check out what the graph tells you, and then either check support or refute with your draw tool. All right, moving on to your hands-on experience today. I'm going to try to do the best I can explaining this. Those of you guys who are doing this at home, you won't have the materials in front of you, so you guys will be using the little shapes on your screen to help you out. And you guys will be kind of working over the next couple of slides. So using cubes to model the passing down of traits. In this activity, we will be modeling a population of individuals using colored cubes. So each cube represents an individual with a different trait. So different colors, different traits. This population's environment is blue, and a predator was just introduced into the environment. So again, they're living in a blue environment, and now there's a predator in that environment. You will be following a set of steps to see how the color traits in this population will change over 4 generations. The starting population has an equal number of blue, purple, and green individuals. Make a prediction below about how you think the color trait in the population will change by generation 4. Okay, follow the instructions completely. So if we have 4 generations of these populations, how do you think they change? Remember that their environment is blue. So do you think that the individuals by generation 4 will be mostly blue, mostly purple, or mostly green? All right, so gather your materials. Again, you guys at home have kind of all your materials in this lesson, so you don't really need to worry too much about that. But what you guys will see in your slides is this data sheet. A graphic organizer is where you guys are going to place your little individuals and your populations. And then you guys will have your bags of population cubes, which are going to be the little colored squares that are kind of grouped accordingly. So create the first parent couple. Shake the bag with the 12 cubes in it and randomly take out 2 cubes at a time. Obviously, this is going to be hard for you guys to do the random part of this, so just do the best you can trying to randomly select parents. Group them together as mates in the parents row of the graphic organizer. So let me show you guys what this looks like. I'm going to skip you guys down to slide 18. You guys will see this is your population bag. These are going to be your offspring bags. So we're going to make our parents out of what we already have in our population. So I'm going to randomly grab and drag my parents over here again, just kind of grab. These are going to kind of represent our couples. Again, you guys can do this however you choose. So you guys are going to fill up all of these little parent boxes right here with these populations. So you guys can see this population has 1, 2, 3, 4 blues, 1, 2, 3, 4 greens, and 1, 2, 3, 4 purples. Okay, so that's what our original population is sitting at. And at some point in this, it's going to ask you to graph your starting histogram. That's what we're pulling that data from, is that 4 blues, 4 greens, and 4 purples. Okay, so you're going to go ahead, group those together, and then create a starting histogram. So on your data sheet, which is the next slide, 19, this is your starting histogram right here. You guys will go up to draw. You'll use your highlighter, and then you guys can see blue, purple, and green. You should have 4 of each, so fill in 4 blocks for each of those with probably your highlighter would work best, and you guys can either color coordinate. All right, blue, there was 4 blue individuals. Okay, how many purple? Purple individuals, 4 of them. Okay, how many green? 4 greens. Okay, and you guys can see that's already in your data table right there. All right, back to our instructions on slide 15. I guess we finished that page. Let's go to 16. Model a generation. Gain offspring from reproduction. Each parent couple has 2 offspring, 1 offspring of each of the parent colors. So basically, if we look at this, if we look at my first little couple that I made, their offspring are going to come from these offspring bags, and they're going to model exactly what the parents look like. So they have 2 offspring. One of the parents is purple, so that means one of the offspring will also be purple. Okay, one of the parents is blue, so again, that's going to mean that the other offspring is blue. Okay, so you guys will kind of go through and do that for all of your parent couples. Again, you guys should have these filled in right here. And then you guys will fill out all your offspring here. It might look different than mine. That's okay. All right. And then, sorry, going back to your instructions. Gain offspring from reproduction. We took care of that. Lose individuals to death by predation. Remember that our environment's blue, but we also introduced a predator in there to see kind of how that camouflage helps or doesn't help them. Okay, predators eat half of all the green cubes and 2 purple cubes. So take a look at all of your parents and all of your offspring, and you guys are gonna drag half of the green to the graveyard and and 2 purple cubes to the graveyard. So here's your little graveyard right here on slide 18. You guys are gonna drag, all right, this green one, if it's part of half, you guys would drag it here, and then 2 purple cubes. So maybe I drag these 2 into my graveyard. Okay, 1, 2. Okay, and then I would go ahead and count how many individuals I have. So place all remaining cubes back in your population bag. Remember, this little square up in the upper left-hand corner represents our population. So you guys can go ahead and clear the board. Anything in the graveyard stays in the graveyard though. So clear just this top part right here. Your parents and your offsprings, you can put them back in your population bag. And then you guys will count that generation. So at the end of that first generation, okay, how many do you guys have? So generation 1, how many blue, how many purple, how many green in your population? Oops, I keep going back to the wrong slide. Let me just get rid of that. All right. Moving on. Replace all 6 cubes back in your population bag. Find mates in the population and create new parent couples. Shake the population bag and randomly take out 2 cubes at a time. Form 6 parent couples in the row. So you're going to repeat this process basically. Now you have your population bag. Grab all your random parents. Figure out what their offspring are. And then this one, you're going to lose remaining individuals to death by old age. Any remaining individuals in the population bag do not find a mate and eventually die without reproducing. So I guess you don't record generation 1 until after we do this old age piece. Okay, so again, you guys would drag all your offspring and parents back to your population bag. Then you guys would make new parents. You would make new offspring. And then anything left in this population bag right here gets drugged to the graveyard. Okay, then you guys can clear out your parents and your offspring again, put them in your population. Then you guys count, and then you record generation 1. So you're going to repeat that process through 4 generations. Okay, and that's all this one says. Repeat step 4. Continue until you have 4 generations of data. Note, if you run out of offspring, you can borrow from the cubes in the graveyard. So if you run out of little offspring in these offspring bags right here, you guys can just refill them from the graveyard. Okay, and then finally, clean up. You guys don't have to do much for cleanup, so lucky you guys. All right, then you guys will draw your final histogram here. So at the end of 4 generations, what did your histogram look like? It should look different than this. Okay, all right. And then finally, we're going to move on to our last couple activities here. You have a little reading. So this article is called Glowing Jellies. If you guys go ahead and right-click to open it up, it'll look like this. So read this short little article about jellyfish that glow, and then answer this question: how do individuals and a population get their traits? Okay, finally, a couple reflection questions that you'll need to use your draw tool for, so you guys can circle the correct answer. Where do the genes that determine an individual's traits come from? You guys can read for your 4 options there and circle the correct one. How do genes determine an individual trait? Again, use your draw tool to correct which one of those 4 is the correct answer. And then finally, how can an individual be born with an adaptive trait? Okay, and then wrapping up, we've got this little modeling tool, Sherman's Story, bird beaks. So this is the same one you guys read about similar to what you guys read about. These birds are so amazing. Their beaks are so strong and tough. Did you know that very long ago they didn't have such strong beaks? Okay, and then it says, now we have strong beaks for them to eat. Oh yeah, they grew stronger beaks, and this guy's like, nah, they didn't do that. That's not how it happened. He's like, oh, so the birds with weak beaks all had offspring with strong beaks. So that's kind of where we left off. So this guy reports, well, no, Sherman, individuals can't just decide which traits their offspring have. The way reproduction really works is, then you guys are going to kind of address that using this modeling tool. So use the modeling tool, beak strength, explanation, student sheet to represent your ideas. Follow the instructions below. Your goal is to create a model to help explain to Sherman how beak strength traits get passed down and how that can change in the distribution of traits in the bird population. So you're going to look at the histogram that I provided you, starting population, and label that with any trait labels that apply. We have some new trait labels to look at this time. And then you're going to predict the histogram 50 generations later. Okay, you guys can add multiple trait labels on a single trait, and you guys can use trait labels more than once, and you do not have to use all of them. All right, so you guys will see we have new trait labels here. This one should look familiar to you. Before we just used a plus and minus. So the plus meant more likely to survive, the minus meant less likely to survive. The O's, on the other hand, are going to talk about reproduction and having more or less offspring. So the plus is more offspring, the minus having less offspring. So you guys can take a look. You guys can see the starting histogram at 0 generations, and then you guys can also see the environment change. The soft seeds turned into hard seeds, and so you guys will predict what your guys' histograms look like after you guys label these. So you guys have one of 2 options. You guys can either do the S plus and the S minus to label these, and the O plus and the O minus to label these, or if you guys wanted, you guys can color coordinate and say, all right, I'm going to write my pluses and minuses in green. So if I look at this and say, all right, these birds with the stronger beaks are going to be the ones that are more likely to survive. I'm going to say, all right, this one would be here and this one would be here. And then there might be more than that, just FYI. And then maybe I'm going to say, all right, well, blue then is going to be my reproduction. So then I'm going to change my color here and say, all right, if I put a plus here, this is going to be more likely to survive and reproduce, okay? And these are going to be more likely to reproduce. So again, it might look different than that. And then finally, draw your histogram as you think it will look. And wrap up by answering this question. Explain why these birds now have strong beaks, even though most of them did not have strong beaks many generations ago. Be sure to include what you know about how individuals get their traits. Finally, complete your wrap up for the day, and you guys can go ahead and hand it in, and I hope you're having a wonderful day. I'll talk to you soon. Bye.